Hello class, this is Professor DeVoe here, and I wanted to come on here to take a look at the exercise that some of us have been struggling with in identifying the slope of tangent lines and the slope of secant lines. So the key is that when you're approaching this problem, you want to draw a picture of the function that's given to you. So let's take a look at the exercise that we have in front of us. This is very similar to the exercise that you saw in or on the quiz, particularly problem number 4. So hopefully you can use some insight on how to approach this problem once we finish the exercise together here. So the problem says that the point P11 lies on the curve f of x is equal to x cubed. It also says let q x sub 0 q be an arbitrary point on the curve. Let s be the secant line drawn from P and Q. Drawn through P and Q. Let the slope of the secant line be drawn through P and Q be denoted by m sub s. And it says find the limit of m sub s as x sub 0 approaches 1. So this is the actual point 1 here, this particular point, that's that dot, that's 1. And we have this blue line that represents our actual secant line that passes through the 2 points on this function. And the red line here represents the tangent line. So in order for us to find the tangent line, which is our ultimate goal, in this situation, when they ask us to find the limit as x sub 0 approaches 1, we're actually looking for the tangent line. To start this process, we have to use some prior knowledge about how to find the slope of a line. So we start by finding the slope of a secant line. So we use m sub s, since we're looking for the slope of the secant line. Recall that the formula to calculate slope from algebra is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And the points that we have here that we're going to use to calculate the slope are the points that are on this secant line. We see the first point here. We'll call it x sub 1, y sub 1, since that is our actual fixed point. And the arbitrary point that we have here for q, we'll call it x sub 2, y sub 2. And we're just going to do some substitution inside the formula for calculating slope. So if we identify our y sub 2 here, in our case, represents our x sub 0 raised to the third power, which is here. So I'm going to write down x sub 0 all cubed minus my my y sub 1, which is represented by here, which is going to be the value 1 for the first point, divided by x sub 0, which represents our x sub 2, minus my x sub 1, which is going to be 1 again. So this expression here represents the slope of secant line. So now we're going to use this information to actually calculate the slope of the tangent line. To find the slope of the tangent line, we have to do the following, which means that we have to find the limit as x sub 0 approaches 1 of m sub s. We already know what m sub s is, which is this algebraic expression here. We're going to replace this m sub s with its true algebraic form. So this means that I'll actually have the limit as x sub 0 approaches 1 for the expression x sub 0 of 3, x sub 0 raised to the third power, minus this 1 all over x sub 0 minus 1. This is what we want to find the limit of, to find the slope of the tangent line. So let's see if we can find a solution by direct substitution. If I do direct substitution, I'll have 1 raised to the third power minus this 1 all over 1 minus 1. And the results that we have is 0 over 0. And we already discussed in some of the previous discussion posts and when you read through the textbook that this is what we recognize as indeterminate form. So that leads us to two or three other procedures that we should approach to find the actual solution for the limit. That means that we either have to divide it out and factor out and cancel out some factors, or we can have to rationalize the denominator to find the solution for the limit. So it looks like for this particular part of the problem, we actually have to, it would be best to factor the numerator. So let's factor the numerator and see what happens here, and hopefully we'll find something that will cancel out with the denominator. So the limit as x sub 0 approaches 1, if I factor the numerator, hopefully we can see or recognize that what we learned from college algebra or from pre-calc, that this expression at the top is a representation of the difference of cubes. We can always factor the difference of cubes. If I factor this, I'll have x sub 0 minus 1 times this x sub 0 all squared plus x sub 0 plus 1 all over x sub 0 minus 1. And what we see here is that we do have common factors that we can cancel out. So let's go ahead and cancel out those two factors, which is going to be this x sub 0 minus 1, x sub 0 minus 1, and that's going to leave me with the limit as x sub 0 approaches 1, x sub 0 squared plus x sub 0 plus 1. Continuing, we can actually now do our direct substitution since it's not an indeterminate form representation. If I do direct substitution, I'll have 1 all squared, 1 all squared plus 1 plus 1, which will give me 3. So this 3 is the slope of the tangent line at the point 1, 1. And that concludes the exercise. So if you have any additional questions, just make sure that you send me an email through GoView